Welcome to Knowledge Base. Let us look at dimensional analysis. And we have a question here that says the distance d traveled by a body in time t if its initial velocity is u and the body moves with a constant acceleration a is given by d equals ut plus half at squared. Check the homogeneity of the equation. So we have given this equation d equals ut plus half at squared. We are to check if this equation is homogeneous, and we are told what each of the terms in the equation stands for. D is distance, U is initial velocity, T is time, A is acceleration, and we are to check for the homogeneity of this equation. How do we check homogeneity of an equation? We check it by checking the units of each term of the equation or the dimension of each term of the equation. If they are the same, that means the equation is homogeneous. However, if the units or dimension of each term that makes up the equation is not the same, then the equation is not homogeneous. So here we are just going to take the terms d, ut, and at squared and check their units to see if they are the same before classifying this equation as either homogeneous or not homogeneous. So let's pick the first term, d. We are using the units, not the dimension. Either of them will give you the same answer, so let's use the unit. The unit of d, which is distance according to the question, is meters. We have checked that. Let's check the term ut. The unit of ut is equals to meter per second for the unit of u, which we are told is velocity, times seconds, the unit of time, t. So we have meters per second multiplying seconds. We can rewrite this in this form, meter all over second times seconds. These seconds cancel this and we are left with m. So the unit of ut is m, which is meters. Now let's check the last term, half at squared. Half is a constant and it does not have a unit. So we are not going to be checking for half. We are just going to be checking for the units of at squared. So unit of half at squared, like I said, half is constant, so we pick the unit of acceleration, and the unit of acceleration is meters per second square, times the unit of time is seconds, so we have seconds square times seconds square. Let's break it down into meters all over second square times second square. The second square, we cancel the second square and we'll be left with m, which means the unit of at square is m. Now looking at each of the terms, unit of d, m, unit of ut is m, and the unit of at square is m. Since all of the units are the same, we can conclude that the equation is homogeneous. So we can say, since the unit of each term of the equation is the same, the equation is homogeneous. Now take note of something. Homogeneity of an equation does not account for the correctness of the equation. An equation can be homogeneous in terms of the units or dimension, but it does not necessarily mean the equation is correct. What we've just checked for is the homogeneity of the equation using the units, and it showed us that the equation is homogeneous. It does not necessarily mean that the equation is correct. So don't mistake the correctness of an equation, the homogeneity of an equation for the correctness of the equation. It means that a wrong equation can still be homogeneous. If you understood what I've said, then try this. Check the homogeneity of this equation, F equals to 2ma plus m into v minus u all over t, where F stands for force, m for mass, a for acceleration, v for final velocity, u for initial velocity, and t for time. Please put your answer in the comment section, and thank you very much for watching this video. If you really enjoyed this video, do well to share this video to others so that they will come to this page and watch and learn exactly what you're learning from this page. And you keep encouraging us to make exciting content. Thank you once more for watching.